All right, in this lesson we will be looking at doing some work with arithmetic sequences. Little cartoon there to get you started here. You can certainly hit pause. All right, so first of all, some vocabulary that need to be familiar with. A sequence is a list of numbers in a particular order. You've seen that a lot. And there's got to be some pattern to that, that list of numbers. A term is each individual number in the sequence. So 5 is a term in this case. 11 is a term in this case. Okay? With arithmetic sequences, you get the next term by adding, or really, if you want to think about it, subtracting 2, because subtracting is really adding a negative. But you're adding a constant, and that number that you're adding is called the common difference, and it's referred to as D. Okay? So not all sequences are arithmetic. This one is. It's going 1, 3, 5, 7. You can see that what you're doing every single time to get from here to here is I'm adding 2. To get from here to here, I'm adding 2. And so then I know that I have an arithmetic sequence. If I have a sequence that looks something like this, this could be another sequence. And here you're not adding. So here, to get from here to here, I would add 2. But to get from here to here, I add 4. And to get from here to here, I add 8. So I'm not adding the same number each time. I don't have a comma difference, and so that would not be an example of an arithmetic sequence. Okay? So if I am in this case, I'm asking you to find the next 4 terms in the sequence. You kind of have to figure out what's going on here. So how did you get from -8 to -5? To get from -8 to -5, I would have added 3. To get from -5 to -2, I would add 3. So again, you're going to continue to add 3. Oops, sorry. I'll continue to add 3. So when I add 3 to this, I get 1. When I add 3 here, I get 4. When I add 3 here, I would get 7. And when I add 3 here, I would get 10. So that's pretty basic. And we'll go from there. Okay? All right. There are 2 kinds of formulas that deal with arithmetic sequences. There's what's called an explicit formula, which we use quite a bit. An explicit formula, the difference between the 2 is that in the explicit formula, you can find any term number anywhere. You can always use it for the first term, the last term, the 8th term, the 10th term, the whatever. And you can use it without knowing anything else. The recursive formula, you can't find a term unless you know the term before it. So that's kind of the difference. Okay? In both cases, though, you sort of need to know this. A1 is the value of the first term. Okay, so if I am looking at the sequence, I'm going to go back to this one, 1, 3, 5, 7, 9, and looking like that. Okay, in this case, the first term is 1. The first term will not always be 1. Okay, for instance, if I had the sequence 8, 5, 2, -1, etc., 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 then your A1 would be 8. Okay, so in this case, my A1 is 1, and in this case, my A1 is 8. So A1 stands for the value of the first term. N stands for a term number. Okay, so is it the 4th number on the list, the 3rd number on the list? What number on the list is it? Okay, so for instance, with this spot right here, it is in the 4th spot on the list. 1, 2, 3, 4. Because it's in the 4th spot on the list, N would be 4, but then AN is the value of that term. So in this case, I would plug in 4 for N, so A4 is -1. Okay? If I look at this one right here, it's in the 1, 2, 3rd spot, so N is 3, but then A3 is 5. Okay? So, just so you know that. And your D is your constant difference, and that's what you're adding or subtracting every time. In the top sequence, my constant difference is 2. In the bottom sequence, my common difference would be -3. Okay? And we will talk about this as we kind of move on here and figure out how to do this. Okay? All right, so here's an example here. I've given you the first term and the common difference, and you are going to figure out the next 5 terms, or the first 5 terms. Okay, so A1, that tells you that the first term is negative 4. My common difference is negative 5, so basically that means I'm going to subtract 5 every time. So negative 4 minus 5 is negative 9. If I subtract 5, I get negative 14. And I can keep subtracting 5, negative 19, subtracting 5, negative 24. Okay, of course they are not always going to come out nearly that pretty. So here's another sequence. This time I want you to notice that I have fractions, and you're going to get fractions, so you're going to have to kind of get used to that. What I want to do is I want to write the formula that will generate this sequence. And that's what I mean when I say use the explicit formula. That's what we're doing in part A here. We're going to write the formula that will generate this sequence. Okay? So in order to do that, I am going to kind of use this. You're going to plug in a number for A1, and your A1 again stands for your first term. In this case, my first term is 16/9. I'm not plugging in anything for n because I'm not trying to find a specific term number. I'm only trying to find a formula that will generate any term. Then your common difference is what you have to add or subtract to get from there to there. And it's maybe, you can probably figure this one out in your head, but in case you don't know, what you can always do is take one term and subtract the previous term from it. So 10/9 minus 16/9 would be negative 6/9, which of course we know is negative 2/3. If I check another spot, 4/9 minus 10/9 would again give me negative 6/9, which of course we know is negative 2/3. So if you can't figure out in your head what's happening, actually go ahead and subtract the previous term from the term you have. So like I took this one and I subtracted the previous term. I took this one and I subtracted the previous term. Either way, I got negative 2/3 as my common difference. Okay? So I will plug in negative 2/3 right there. Okay? I'm going to erase this so that I have some workspace later. All right, now what I want to do is just simplify this explicit formula. You're not going to have a numerical answer here. You're still going to have variables and and that kind of thing, but you are going to need to simplify this a little bit. So I have 16/9 here. I will distribute this negative 2/3, so then I will have negative 2/3 n plus positive 2/3. And then what you want to do is you want to combine your like terms. So I have negative 2/3 n, and then I need to be able to add 16/9 and 2/3. So I will make that 2/3 be 6/9 so that I have common denominators. And then 16/9 plus 6/9 would make 22/9. And this is the formula now that will generate any term in that sequence. If I want to find the first term, I would plug 1 in for n. If I want to find the fifth number on the list, I would plug 5 in for n. But that sequence now, in an explicit formula form, will be able to find any term number on that whole entire list. Okay? So, using that, I now want to find A20. So I'm using this formula right here, and what I will do is I will plug 20 in for n. Okay, I want to find the 20th number on the list. That's what this is asking me to do. Find the 20th number on the list. So, A20 will be negative 2/3 times 20 plus 22/9. So the 20th term on the list, that's what A20 means, is what's the 20th term on the list, will be negative 40/3 plus 22/9. And of course you can use your calculator to help you if you want, but I think you'll probably be able to handle this. If you want to get common denominators, then you would change this to be 120 over 9, and negative 120 over 9 plus 22 would give you negative 98 over 9. And that does not reduce, okay? Or of course you could have gone to your calculator and just typed in negative 40/3 plus 22/9, hit math, enter, and gotten it. But you need to know this. On a quiz or a test, you guys, I will make you use the formulas to show me this. I will not allow you to list 20 numbers out and just make a list until you get to the 20th number and circle it, I will require you to use formulas like this. And I will probably give you really big term numbers, like find the 500th term, because nobody's going to want to sit and make a list of 500 numbers to get to the 500th one on the list, okay? So know that you're going to be forced to use the formulas, so go ahead and get used to that. All right, this is the same sequence now as we were dealing with before, but this time I want you to write a recursive formula, and I will sort of show you how this works, okay? So to find the recursive formula, then we already know some things about it. So I know that the first term right here is 16/9. So when I make this formula, what you tell me is I follow this part right here, okay? And I'm telling you that the first term on the list is 16/9. Then what this means is this. To get any term, that's what this means, what I do is I take a n minus 1. And that means it's the previous term, and I add my constant difference to it. And you do have to say that n has to be greater than 1 because you can't have the 0th term or a negative term, a negative number on the list. It's the negative 5th spot. There isn't such a you start counting your spots as this is the first spot, this is the second spot, okay? But you can't have this is the negative 5th spot on the list because that's not how it works, okay? That's why you have that n is greater than 1 back there. Anyways, what this means is that to find any term, I take the term before it, that's what a n minus 1 means, and I add my difference, okay? Now, in this case, we already figured out from the previous problem, since this is the exact same sequence, I figured out that my common difference was negative 2/3. So plus negative 2/3, and really I would probably change that plus a negative to a subtract sign. Okay? All right, now it says use that formula, the explicit formula now, to find the 6th term. Okay, here's where this gets tricky. Okay? So I'm using kind of this piece right here. Okay? So here's what this means. To find the 6th term, I take the 6 minus 1 term, which of course we know is the 5th term, and I subtract 2/3 from it. Okay, so again, to find the 6th term, I take the 5th term and I subtract 2/3 from it. The problem is I don't have a number to plug in here. I do not have a number to plug into A5. So I better find A5. So if I want to find A5, again, I'm using this formula. To find A5, I have to find the term before it, which we know is the 4th term, and subtract 2/3 from it. But guess what? I don't know the 4th term either. So to find the 4th term, I have to take the 3rd term and subtract 2/3 from it. Do you see how this gets tricky? You can't find any term unless you know the term before it. That's why recursive formulas are not always very helpful. Okay, same thing. I don't know the 3rd term on the list. I don't have a number to plug into this list. Okay, and actually I do in this case, but I do have that the 3rd number on the list is 4/9. So here we go. I'm going to plug in 4/9 now minus 2/3. Okay, and if I plug in 4/9 minus 2/3, then I will get negative 2/9. Okay, so now I know that A4 is negative 2/9. I'm going to go and I'm going to plug that in right there. So now I can go negative 2/9 minus 2/3. And I will get negative 8/9. So now I know that the 5th term on the list is negative 8/9. I can plug that in. To find the 6th term on the list, I take the 5th term, which is negative 8/9, and I subtract 2/3 from it. And when I take negative 8/9 minus 2/3, I will get negative 14/9. And this is your grand final answer. So the 6th term on the list is negative 14/9. But I couldn't find that 6th term unless I knew the 5th. And I couldn't find the 5th unless I knew the 4th. And I couldn't find the 4th unless I knew the 3rd. That's what recursive formulas are. Okay? All right, now what I'm giving you guys is I gave you a specific term number and I'm asking you to figure out, is it in what spot on the list? Okay, we know this is the first spot, second spot, third spot. I've got a whole bunch of things in between and this is the what spot. Again, on the Quizera test, I will make you use formulas to do this. I will not allow you to just fill in the blanks here until you get to negative 140 over 9. You will need to use the formula, so you might as well get used to that. So we are using this formula right here. I know that 16/9 can be plugged in for the first term. This is the same sequence we've been dealing with. I know that my common difference, we already know, is negative 2/3. Okay, same sequence that we've been dealing with. And now what I want to do is I want to find basically what n is. I don't know. This is the first term, second term, third term. I don't know what term this is. This is the piece that I need to find that I don't know. Okay, I don't know what number it is on the list, but I know the value of that term is negative 140 over 9. This is what gets plugged in for an. Okay, so here we go. I don't know what term number it is, but I know the value of that term is negative 140 over 9. I'm going to plug that in for an. I know my a1 is 16/9. I don't know my n here. I don't know what term number that is. I just know the value of it is negative 140 over 9. And then I know my constant difference or my common difference is negative 2/3. Okay, so now my goal is to be able to solve for this. Of course, I will distribute that negative 2/3 through, and I will have negative 140 over 9 equals 16/9 minus 2/3 n plus 2/3 when I distribute. Combine your like terms right here. Okay, so negative 140 over 9 equals negative 2/3 n plus 22/9. Okay, I will subtract 22/9 from both sides. And when I subtract 22/9, I get negative 18 equals negative 2/3 n. And then to solve for n, I will multiply by negative 3/2. And I will get 27. 1, 9, and 27. Okay, so what that means is that negative 140 over 9 is the 27th number on the list. Okay, that's what that means. All right, here's what this says. Write an equation for the cost to rent the Viper for n days. And this is what you have. Okay, so to rent it for 1 day, it's $7.99. To rent it for 2 days, it's $12.98. To rent it for 3 days, it's $17.97. So you're going to kind of use this information right here and go from there. Okay. And then you have to figure out how much would it cost to rent it for 14 days. Okay. So here we go. We're going to be back here. Write an equation for the cost to rent the Viper for n days. I don't know if you'll be able to see this on here, but I will try to extend this page and bring it down here. All right, for n days, again, I'm going to use this formula right here. Okay. I know that my first term is $7.99. I am not trying to figure out, I'm not plugging in a number for n because I want to just make a formula that will work for any number of days. So I'm going to just do that. Then I need to figure out my common difference. In order to figure out your common difference, you'll subtract those two. And if I take $12.98 and I subtract $7.99 from it, you can see that it's $4.99 is your common difference. And then you'll have your an here. And then, of course, I want you to simplify this and just combine your like terms. So I have $7.99 plus, if I distribute this through, I have $4.99n minus $4.99. And then an will be $4.99n plus 300. Okay, now if you can't figure out what that means, in this case n is going to stand for the number of days. So if I rent it for 1 day, it's going to cost me $4.99 times 1 plus $300. If I rent it for 8 days, it'll be $4.99 times 8 plus $300. Okay, so that $300 is sort of like a deposit that you have to put down. You probably won't get it back, but like a setup fee. And then you're going to pay that setup fee one time and then $4.99 for every additional day that you rent it. Okay, so if I want to figure out what the cost will be for 14 days, I'm going to use that same equation from the previous page. So I'm just using that $4.99n plus 300. And then, of course, I will just plug in 14 for that. So I'm looking for the 14th term on the list. I don't know what the 14th number on the list would be. And again, you're going to need to use formulas for this. On the test, you will not just be able to write out 14 numbers and circle the 14th. Okay. So when I take $4.99 times 14 and add 300, I should get $7,286 to rent that Viper for 14 days. All right, and then the last one, if a person paid $5,290 to rent this car, how many days did they rent it for? Again, you're using that same equation that we have simplified back a couple of problems ago. This one right here. Okay, and this time, if I know they paid $5,290, how many days did they rent it for? That 5,290 is going to go in for AN. And then you need to solve for N because I don't know how many days they rented it for. So N in this case stands for the number of days. So I will subtract 300 and I'll get 4,990 equals 499N. Divide by 499. And of course N comes out to be 10. And in this case that would be 10 days. And that is an introduction to arithmetic sequences.